Hello everyone, in this video I'll be explaining the problem different distances. So this was asked in educational code forces round 191 for rated for unit use and 2. So let's read out the problem. Construct an array of foreign integers, basically 4 times integers, such that each number from 1 to n appears in the array exactly 4 times. Okay, if there are n integers, definitely if the size of the array is 4n, so there has to be four appearances of each element. Now they have said if p of x comma I be the position of the ith occurrence of number x in the array, okay, then for each x from 1 to n, then for each x from 1 to n, the number p of the number x which has appeared second time minus p of number which appeared first time, again third apparent position, second apparent position, fourth apparent position, third apparent position. If you subtract this three, so must be pairwise distinct, all the numbers has to be distinct. They have also given example, they have given n is equal to 3, so it's a good example only. Yeah, if you see, let's take this example on the iPad and understand. Okay, so they've given test cases, and we have for each case we have just a single integer. For particular integer, we start from 2 to 200. We definitely have a solution. We can make arrangement, so we have to display the array, right? So let's go to the iPad. So it's a problem B. It's a B problem. Different distances. Now input they'll give simply n, right? Our task is we have to display array. We have to display array of size 4 times n. And what is n? N is basically a non-negative integer, or you can say positive integer, which will be from 1 2 3 up to so till n. And since array size is 4 times of n, they have made sure some of the restrictions that number 1 this has to appear 4 times, number 2 also has to appear 4 times, number 3 similarly, all elements similarly 4 times. So basically if you take array element as ai, not array element, or we can take number from 1 till n, this all number, right? One number particular, let's say 1 2 3 or something like that, all numbers has to appear 4 times. So definitely, yeah, since we have n numbers, and if all numbers appear 4 times, the size of the array is going to be 4 times f n. Okay, now the question what they've asked is, let's say p of x comma I. P is basically position in a sense. We have 4 times of array size, right? So this is, if you consider one based indexing or something like that, so this is the third position, right? Here we have first, second, 3 4 5, this is third position. So p of x comma is basically third position, wherein x is basically the number, it belongs to 1 till n. And what is I is basically the occurrence means it has to appear 4 times, right? So I will indicate the first occurrence, second occurrence, third occurrence, fourth occurrence, right? So now the question what they've said is p of this particular number x, which is at second occurrent of that number, the position of that will be, let's say, this thing. Now position of the same number, the first occurrence time, if you subtract, you will get some number, let's say x. Similarly, if you take position of position of x, which is at third occurrence, minus if you do position of x which is at second occurrence, its distance is going to be y. Similarly, we have fourth occurrence minus the third occurrence. If you do, its position is z. So this all three has to be pairwise distinct, in the sense x has to be not equals to y has to be not equals to z has to be not equals to x. These two if you take, these two if you take, or these two if you're taking, all the three has to be pairwise distinct. Basically what they're trying to say is, if you take n is equal to 3, and when you try to position their array elements this way, 1 2 3 1 2 3 1 2 3 1 2 3, these are the elements, right? Now if you see, this is the first occurrence of 1, this is second occurrence of 1, this is first, this is second, sorry, yeah, 1 is here, right? This is third occurrence, and this is fourth occurrence. Now if we see the distance between them, what is the distance? 1 2 3, so distance is 3. Again similar, if you see here, the distance is 1 2 3. If you see here again, it is 1 2 3. So if you take the distance here, all are same, right? So this array is not a valid one. Okay, this array is not a valid. So how do we arrange? Well, there are a lot of ways to do it, but what I try to do in the contest is just, first I took the example, and for n is equal to 3, I just 3 times of 4 is basically 12. So we have 1 2 3 4 5 6 7 8 9 10 11 12. These are basically positions or index. Now let me copy paste the value, the answer value, whatever they have given in the problem statement: 3 1 3 2 2 3 3, right? So this is the answer value they've given. So if you take we have n is equal to 3, right? So we'll take each element, right? Let's say x is the element from 1 to n. Now x is equal to 1. So if you see x, this is the first occurrence of 1, this is the second occurrence, this is third, this is fourth, and this is fourth. Now distance between first and second, if you see, the distance is simply 1. Distance between 1 and second and third occurrence, if you see, 1 2, we have 2. The distance between third and fourth, if you see, we have 1 2 3. So if you see, this is 1, this is 2, this is 3, all the distances are different, unique. So this is a valid arrangement for 1. Now let's see for second, for x is equal to 2, this is first occurrence, this is second occurrence, right? Distance is 2 here. This is second occurrence, this is third occurrence. What is distance? 1 2 3 4. This is third occurrence, fourth occurrence. So distance is simply 1. So similarly, if you see for third one, 3, this is first occurrence, this is second occurrence, distance is 2. This is second occurrence, and this is third occurrence, distance is 3 here. And this is third occurrence, fourth occurrence, distance is 1. So if you see, all the values are different, right? So this is valid arrangement, this is also valid arrangement. So we have to make sure for the given n, we can display the array in this way. So in the problem, in the contest, what I was trying to do is, I was trying to make sure I'll just insert 1, since n is equal to 3, right? There will be 12 positions, because array size will be let me call length, it will be 4 times of n, which is basically 12. 4 into 3 is 12. So in the array, what I was doing, in the contest, what I was doing is, right, so I was writing 1 here, then I was writing one more 1 here. Okay, since distance 1, now I'll have to make sure distance is 2. one more 1 will come here. No, distance is 3, 1 2 3. So one more 1 I'll send here. For 2, since this is valid as well, for 2 I was writing 2 here, then 2 here. Now one more 2 could be here distance 2, now distance has to be 3, so I was inserting 2 here. And one more 2, it has to be a distance for 1 2 3 4, I think. Yeah, 1 2 3. So in this way I was actually doing it, right? Like basically trying to insert, but I did not get any pattern kind of thing from here. So might be you can get pattern from here. But one thing I made sure is this word is very important, distance. So when we are doing a distance, right? So what I try to do is we'll have to make certain arrangements. So what I did is for n is equal to 3, I just made 1 2 3. I just simply put, then I reversed this arrangement 3 2 1. Okay, so 2 times I have inserted the all numbers. Now we have to insert the third time and the fourth time. Okay, so what we can do is you have this arrangement, right, starting 1 2 3. Now you make sure you shift this one to the end, so it is going to be 2 3 1. So I just made this arrangement and then I reverse this again 1 3 2. So if you see this, this is also a valid arrangement, right? 3 has a distance 1 here. If you see 3 has a distance of 4 here. If you see 3 has a distance of 3, so already different. 1 if you see has a distance of 1 2 3 4 5, right? Here if you see 1 has a distance of 1 2 3. Here if you see 1 has a distance of 1. Similarly 2 if you see has a distance of 3. Here it is a distance of 2. Here it has a distance of 1 2 3 4 5. So this is also a valid arrangement. Now how I came up with this is that I made sure ki 1 2 3 when we are inserting, so here the since we don't have any elements, so distance will be kind of we cannot calculate the distance. Now once I reverse the element, I'll get distance between two elements, because the occurrences of right now here are 2. Now again if you insert 1 2 3 and then 3 2 1 if you do, so this will also give I think yeah, this is also a valid one. No, it is not a valid one. The reason being I'll tell you. Since you have 1 2 3 in a linear fashion, one arrangement you have as a one combination or one permutation, you reverse it and then insert it. The same permutation you cannot insert here, because if you insert that, okay, if you insert that same permutation and reverse when you reverse it and then insert the same, so here the distance whatever you have, right, 1 2 3, same distance here also it will be 1 2 3 only. So that's the reason I made one rotation, so that we'll get the second combination. Okay, and why I did not choose like the second as 1 3 2, because one my first combination was this, then my second combination is now this. Now one has not moved from its position, so it may happen that when you insert that, right, let's say I'm inserting, okay, let me insert and show you. We have 1 2 3, we have 3 2 1. This is the first permutation. Now second, if you take 3 2 1, 2 has changed its position, 3 has changed its position, but 1 has not changed. So if you insert now this, what will happen is 1 3 2 and then 2 3 1. So the distance here of 1 is 1 2 3 4 5. Here also it is same 5. So for that reason I made a shift, so that all the positions of the element in the previous combination whatever we had, it has to be shifted, and we can insert that and reverse it. So definitely this is going to help, and yeah, it is going to be accepted. So I think we got to know it was basically kind of a trial error. You should we should have tried multiple test cases and we would have understood. So let's try to code it up. So we have test case and we have integer n. Only two things we are getting. As I said, first will be normal 1 comma 2 comma 3 comma up to so on, an arrangement. So let's take right, we need to display this. Num we are displaying and it is separated by a space. Now we have to do a reverse of this thing, right? So it is gonna be this way: num is equal to n, num greater than 0, num minus minus. We'll copy this same thing. Now the thing is what I said, you need to make one rotation. So when you're doing rotation, so we'll start from 2 first, then 3 we have, then up to so on we have n, then will come 1. So the same thing we'll do. So we have displayed from 2 to n, right? So 1 is missing, so we'll be displaying 1 now. Right, we have displayed 1. Now reverse of rotation, it's basically 1, then we have n up to so on, we have 3, we have 2, right? So first we need to display 1, so we'll display 1. Right, from n to 2 it is going to be displayed. Let's copy the same thing. My bad, oops. At the end we have to do end L. Right, now if we try to run the test case, here it is going to fail because they are expecting in some order, but we have in some order. But if you try to submit the code, it is gonna be accepted. Different distances, yeah. Different distances, yeah. Let's try to submit. Yeah, it is also accepted. So if you try to analyze the time and space complexity of this space, we are not using anything, I mean we are not using any vector or something like that, so it's gonna be constant, but we are using for loops, so it's a linear time complexity, like 4 times we are running, so 4n. Yeah, so thank you guys for watching the video.